Objective number 5. Use the graph to locate the absolute maximum and absolute minimum. The definition of absolute maximum and absolute minimum are very similar to the definition of local maximum and local minimum. There's a difference that we need to notice is that the absolute maximum and absolute minimum require the interval have to be close. Close interval is that you look at the graph and you see that this is the graph and the interval that is between is formed between A to B, and you see the close point at A and B, so this is called the close interval. For the local max and local min, the 2 points that you see from the graph, they are the open point, so the interval is the open interval. In the example number 5 below, they are giving us 5 graphs and they're asking us to find the local max, local min, absolute max, and absolute min. We recall in example number 4, we learned before to find the local max, we just need to looking for something like this, like a V or like a mountain, and the point is on the top of the mountain. To find the local min, we're just looking for the valley. It's the bottom point. It's like a V, but it's in the lowest one, in lowest point. So we're gonna find the local max and the local min first for the 5 graph. So you look at this point, we're gonna go with the local max first. So let's look at this pink point, 3,6. It's like the top of the mountain. It's something like this. It's like a V upside down. We are looking for something like V, but upside down like this. And you're looking for the point 4,3 in E. So we answer 3,6 and 4,3. They are both local max. The other graph we do not have. Now we're looking for the local min. Local min, we are looking for the points that in the bottom like this. For the first one is 4,4. In problem B, this is open, so this is does not consider the point belong to the graph. Okay, so we do not count that point as the local min. Local min appears in problem C is we have like many points in the interval from 1 to 2 from the x. So we answer the whole interval in problem C, that is local min. The interval is from 1 to 2. And also in part E, we have this point is like a V. However, that point is open also, so we do not count that point as the local min. Now we find the absolute max and absolute min. Once again, we go back to definition of absolute max and absolute min. We require the interval have to be close. We look at the 2 graph D and E. This considered not close. In problem D, the graph going up forever, so we consider this is open, this is not close. And problem E also the same thing. This is not close. And 1,4, this is open, this is not close. So D and E, the interval is open, is not closed, so it does not have the absolute max and absolute min. So absolute max is none for part D, and absolute min is also none for part E. Now A, B, C, they are closed interval, so it has the absolute max and absolute mean. Absolute max means if you are at that point in the graph, you are the highest point. You are at the highest point. So we look at the point 3,6. If you are here, you are the highest point compared with the other point. So local max is 3,6. And in part B, the local max will be 5,3. In part C, local max is 5,4. So those orange points, if you are at those points, you are the highest. Okay, now we're gonna look at the absolute mean. Absolute means happen when you are at that point and you are the lowest point. So for the first one, look at that purple point. It is the lowest point. In problem D, because this is open, so we do not count that point as a absolute mean. And problem C, we have the whole interval for the absolute mean. So absolute mean appear from 1 to 2. After we list the point, we need to answer in the proper way. For example, how do we answer 3,6 for the local max? We answer like this. F of x has a local max at x equal 3 and the value is f of 3. When you plug in 3, you got the value is 6. So 6 is the value and the location is at x equal 3. Or you can answer for this point 4,4. We will say f of x has a local mean at x equal 4. The value f of 4 is 4. Or for example, you want to answer the absolute max for the point 5,3. We will say f of x, that is from, this is part A, and this is from part B. F of x has a absolute max at x equal 5. The value is f of 5 equal 3. Or you can say the absolute max value is 3. And for the interval, for example, what if we want to answer like this? So that is part C. So we say f of x has absolute mean in the interval from 1 to 2 and the value is 1. Right here is the 1, which is the white part. So there are some examples that how we answer properly for the local max, local mean, absolute max, absolute mean. But my suggestion is we need to find the points correctly first